Congratulations, you have found the most important video of this tutorial series where we are building a mixed reality game from scratch for the meta quest in Unity. Now, after using nav mesh to make the ghost move to the player's position, in this episode we will do the whole gameplay by spawning some orbs in the scene that the ghost will chase and eat, and that you will be able to protect by shooting the ghost with the ray. In the next one, we will learn how we can customize the path-through and use a stencil effect to make this cool flashlight that will reveal the ghost. So if you haven't already, make sure to subscribe and like this video to not miss it. As always, the source code is available on my Patreon if you'd like to support my work and even get access to exclusive content. And of course, this is your weekly reminder to go and try Cognitive 3D for yourself. Cognitive 3D is the sponsor of this tutorial series. It is not only a free tool that allows to gather data about how your game is being played. With Cognitive 3D, you can even watch replay of your player, get comprehensive data about their session, know if your game meets your objective with its objective system, and so much more. So don't wait any longer and register for free with the link you will find in the description. But without further ado, let's get started. Okay, so we are back where we were left at the end of last episode, and now we have a lot of work for today's tutorial. So first we need to kill the ghost with the gun, then we need to spawn the orbs, then make the ghost find the closest orb to eat them, and finally trigger a game over if there is no more orbs on the scene. So first, if we go to the asset, then you can see the ghost that we made in the previous episode. If I double click on it, we can go into prefab mode. And what I'd like to do is create a death animation for the ghost that we will be able to trigger when we hit the ghost with the ray. So for this, I'm going to click on add component and add an animator. Perfect. Once created, you can go to the animation tab over there, which you can open by clicking on the three little dots, add tab, and then click on animation. Beautiful. When it is done, we can click here on create, and I'm going to call this one ghost death. Beautiful. Now for the death animation, I'm going to click here to start recording and then go into the ghost model that we have. And what we can do is actually change here the material value. So for the initial color, I'm going to right click, copy. We can just change the color. And as you can see, this has created a key for the animation that will be used for the start value of the color. Then I can close this window, pass back the value that we copied at first. So this means that we will start with this initial value. And then I can move here the animation a bit later, let's say a tenth of a second. And I'm going to change the color to something red, like so. Beautiful. And already if we go from the first to the second keyframe, you can see the animation playing, which is already looking great. So then I'm going to go on to the next keyframe at a tenth of a second later. And what I like to do is here change the alpha value and set it to 0. This will make our ghost fade away when we shoot at it. And there you go, this is the result animation that we have. So first we get from the initial color and we lerp to a reddish color and then it just fade away. And this is at this moment that we can destroy our ghost. Okay, so now that we've created the animation, let's click here to disable the recording mode. We can even disable the preview. And now if I go to the parent, we can see here our animator, which has a ghost controller animator. So if we go to the animator tab, which you can open if you go to Windows, Animation, and then Animator. So here, as you can see, by default, we have the ghost death animation, which is playing. It means that if I click on play, it will directly play the ghost death animation, which is not what we want. So instead, I'm going to create an empty state like so, which we can set as a layer by default state. And now to trigger the ghost death animation, what we can do is right click and make a transition to the ghost death like so. And we can control the transition with, for example, a trigger parameter. So if you click on parameters over there, we can click on the plus button and add a trigger here, which I will call death. Beautiful. And now on the animation, if we go to settings, for the condition, we can click on the plus button. And here, as you can see, it has directly set death trigger to be the condition to go from the new state to the ghost death animation. Oh, and also make sure to disable here the has exit time. This will make sure that it will not wait to trigger the ghost death animation. Now, anyway, we can save, go back to the scene. We can click here to leave the prefab editing tool. And now our goal is to call this death animation from the Raygun if we hit a ghost with the gun. So if you remember, if I go under the right and enter, this is where our Raygun is, with here the Raygun script that we made in the first episode. So let's double click on it to open it and be able to edit. Okay, so if you remember, this is the function that shoots a ray and which will actually call a ray cast, and if we hit something, we will spawn a ray impact, and otherwise we will just give a default value to the end position. If we hit something, we want to make sure that it is either a ghost and that we play the death animation, or if it's not a ghost, we can just do what we've done before, which is spawn an impact. So to do so, I'm going to get the ghost script from the hit point with it.transform.getComponent in parent, and the component we want is the ghost component. So in the case that there is a ghost and that there is this ghost component, what we can do is simply kill the ghost over there by calling the ghost.kill function. And otherwise, we simply need to do as we've done before, which is instantiate a ray impact. Okay, so at this point we have two use cases, one where our Raygun finds a ghost and another where it finds something that is not a ghost. And at this point we need to call here a kill function on the ghost that will be able to animate our ghost and then to destroy it. So for this, let's simply press on the control key and click over there on the ghost component to directly go in the script to add this function. And now I'm going to call a public void function called kill. Beautiful. Now on the kill function, what we can do is first we can disable the agent, which means that the ghost will stop moving. And by the way, in the update function, we can first check that if there is not agent enabled, we can simply return. And now I'm going to go at the top and add a public animator reference to the animator that we have created just before, and simply do animator.setTrigger and use here the death trigger name that we've used. And beautiful, by calling this function, we are disabling the agent and then triggering the animation. So what's left is to go back to the Raygun and simply do ghost.kill. Beautiful. There we go. Now we can save and go back to Unity. Now there is nothing to set up for the Raygun, but if we go to our ghost, you can see that on the ghost script, we are missing a reference to the animator. So make sure to drag it over there. Beautiful. Oh, and something very important also that I've forgotten is that if you go to the ghost animation that we just made, make sure here to uncheck the loop time, otherwise the animation will keep on looping every time, which is not good. So anyway, let's save now and click on play to find out if this is working. Okay, so right now there would be some bugs by shooting the ghost, because if we double click on it, you can see that we have here a nav mesh agent, and on the child we have no collider except the one that is sitting here on the eyes, which is something we don't want. So let me go on the quad and remove this component, and instead I'm going to go on the ghost and add a capsule collider. Beautiful. Now if I change the height, you can see that the collider is oriented along the y-axis. Let's change it to the z-axis instead, and we can maybe tweak here the height and the radius of the capsule to have something that feels nice. Beautiful. So now we have actually created the capsule collider that the Raygun will be able to find. We can leave the prefab selection. And another bug that I want to avoid is that if you go to the ray impact, you can see that we actually left the mesh collider on the ray impact. And this is bad because it means that this will add some collision that we don't want. So let's simply right click and remove it as well. Keep a minimal number of collision. And beautiful, now everything seems to be good. Let's click on play to find out if this works. And there you go, as you can see, it works. I can actually kill the ghost and trigger their death animation. But as you can see, the eyes are still showing, which is not good because it means that we have not destroyed the ghost after the death animation. So let's go back to Unity and fix this. Beautiful, this will be very, very simple. We need to go, if we select our ghost prefab, there we go, we can go on the animator here and we can go into the ghost death animation. And what I'm going to do is here, create an event. There we go. Now an event is a function that we can call from the animation. And now you guessed it, I'm going to go on the ghost script and I'm going to create here a public void destroy function that will simply destroy the ghost game object. Yeah, perfect. If we save and go back to Unity, There we go. Now if I click on the event that we've just created, I can go in the function, go to ghost method, and then select the destroy function, which will make sure that after the animation has played, it will destroy the ghost game object. Oh, and one more thing that we can do if we go in the Raygun, actually in the case that we have a ghost, we can even disable the ghost collider by doing it.colliders.enable equal false. This will make sure that we cannot shoot twice the ghost while it is in the death animation. Now anyway, let's save and find out if this is working. And there you go, as you can see it is working. Now I can shoot the ghost, trigger the death animation, and the ghost is completely destroyed after playing the animation, which is what we want. Anyway, now that means that we have finished with the first part of the gameplay, which is be able to kill the ghost, but now we need to spawn some orbs that the ghost will want to chase. So for the spawning of the orbs, I'm going to do a little bit the same as we've done for the ghost, but just spawn a certain number of elements at the start of the game. So let's right click, and for the orb itself, let's simply right click in the hierarchy, go to 3D object, sphere, beautiful. This will create, as you guessed it, a sphere. And now if we right click on the assets, create material, I'm going to call this one orbs material. And what we can do is actually use the same shader that we've used for the ghost, but this time for the orbs. So let's simply drag this orbs material on the orbs. And what I'm going to do is increase the power and change maybe the color to something yellowish, like so. It looks good. Now anyway, we can give it this size, and I'm going to rename it orbs. Beautiful. And we can drag it in the asset folder to turn it into a prefab. Then we can remove the one that we have in the scene, and I'm going to create an empty game object that we can call orbs spawner, which we can reset its position and add as a new component a orb spawner component. As always, at the top, I want to add using meta.xr.mr utility kit namespace. Then for the parameters of the script, I'm going to write a public int called number of orbs to spawn that we can set initially to 5. Then we need a public game object reference to the orb prefab that we will spawn. Finally, we can add also a public float height, which will be the height of the orbs when they spawn. And now we can remove the update function, but on the start function, what we can do is call mruk.instance.register scene loaded callback. And then we can create a new function called spawn orbs that we can call inside the register scene loaded callbacks. This means that when mruk will be finished to registering the scene, we will directly spawn the orbs inside the scene that we've just registered. Okay, so to spawn the orb, let's do for and loop index that goes from 0 to the number of orbs that we want to spawn. I'm going to then create a random position that we can initialize to vector3.0. So now that we have initialized a random position, we can get the mruk room that we are with room equals mruk.instance.getCurrentRoom. Beautiful. And now with this room, if you remember, we can generate a random position on the room surface, and this is what we will do. We can first get a as found boolean and do room.generate random position on surface. Now for the parameter, the first is the surface type, and the one that I like is the floor, so let's do facing up. Then the second parameters is the minimum distance to the edge, so let's set it to 1 for example. Then it is the label filter, and in our case, because we want to spawn on the floor, let's do label filter.included mruk anchor.sceneLabels.floor. This will include the floor label for the spawning. And finally, we can output two things, the random position and the normal. So let's do out random position. So this will set the random position that we've initialized over there. And for the position normal, we can simply do out vector3n. So we won't use this value anyway. And there you go. Finally, with this random position, let's set maybe the random position.height to be the height that we've set as a parameter over there. And there you go. With this value, we can spawn a new orb by doing spawn equal instantiate, and there give as a parameter the orb prefab with the random position. And for the rotation, we don't want any, so let's do quaternion.identity. And there you go. At this point, with this function, we are able to spawn a certain number of orbs. And what would be great to do is actually gather a list of these orbs in the scene. So let's do at the top, public list of game objects, spawn orbs, beautiful. And at the end, we can simply do spawn orbs.add and add the spawn one that we just did. Okay, so this is great, but of course there might be an issue with this if you remember the ghost spawning episode. And the issue is that sometimes the generation of a random position on the surface is not possible. And in this case, the asFound value return false. So in this case, what we want to do is actually retry again and again till we have found a position. So to fix this, what we can do is simply go at the top here and add two variables, a public int called max number of try, which we can set to 100, for example, and a private int, this time called current number of try, which we can set initially to 0. And so instead of here generating a random position only one, what we can do is do it a certain number of times until we have found a value by doing while current number of try is less than number of try. And in this case, we want to generate the random position. If we have found something, then we will break the loop. And otherwise, instead of breaking, we will simply increase the current number of try. This means that the while loop will always increase until either it breaks because it has found something, or that it has not found a random position with the max number of try that we give him. Okay, and here we go. As I think our script is now done, we can save, go back to Unity. You probably know the next step. As you can see, the orb prefab, we can drag the orbs that we created previously over there. For the height, let's set it to maybe 1 meter, and the rest I can keep it this way. So now, as you guessed it, only one thing to do, and it is to click on play to find out if this is working. Look how cool this is. So after just loading the scene model, we have now generated 5 random positions in the scene, and we are able to spawn 5 orbs that, well, the ghost will be able to chase in a minute, because now, for now, they are just trying to chase me. So anyway, now that we've succeeded to spawn a certain number of elements in the scene, let's edit the ghost script to be able to chase one of the ghost scripts instead of me. Okay, so this shouldn't be that hard if we click on the ghost and that we double click on the ghost script. Here, as you remember, the target position that we gave for the agent is the position of the main camera. So instead of giving the main camera position, we want to give it the closest orbs from the ghost. So for this, let's simply do public GameObject get closest orbs. There you go. Now in this function, we can create a GameObject called closest that we can initialize to null and get a float called min distance that we can initialize to mat.infinity. And so in my case, I want to loop the list of orbs that we have. Now to easily be able to access all of the orbs, what we can do is go on the orb spawner. And as you can see, there is the spawn orbs list that actually does this. But what I'm going to do is create a public static orb spawner reference called instance. So this will be a singleton. And we can actually set on the awake function the instance to be this script. Now, because this variable is static, it means that it can be accessed from the other script directly without reference. So let's go back to the Go script. And as you can see, I can get the list of GameObjects orbs by doing orb spawner dot instance dot spawn orbs. Beautiful. Now that I've gathered the same list of orbs, we can loop them with a for each. Then we can get the distance from the ghost by doing transform.position to the orbs by doing item.transform.position. Beautiful. And if the distance that we get is less than the minimum distance that we have currently, what we can do is set the minimum distance to be the d value that we just found and set the closest GameObject to be the item that we are currently at. And there you go. Now at the end, after looping through all the orbs, we can simply return the closest game object that we have found, the one that will be set when its distance is less than the current minimum distance that we are calculating. Now, beautiful, this is getting good. Now what's left to do is to get the closest by doing game object closest equals get closest orb. And if there is a closest, this means that if there is an orb to chase, then in this case, we can set the target position to be the closest .transform.position. And there you go. Now this should do the work. Now we can save and go back to Unity to see if this is working. And there you go. Look at how cool this is. So now you can see that the ghost that is trying to chase the closest orbs from him. And this works for all of the other. Instead of trying to chase the player, now they are currently going on the correct one. For example, if I just move it, you can see that they are chasing the others, so always the one that are the closest. But right now there is two little issues. The first one is that I think the orb's height spawning is a bit too high, and then we want the ghost to be able to destroy the orb if it reaches it. So let's leave play mode and find out how we can fix this. So for the first issue, which is changing the height of the orbs, we can simply go over there, and for the height, let's set it to 0.7. And now to let the ghost eat one of the orbs, what we can do is go to the orb spawner script, and I'm going to create a new public void destroy orb. Beautiful. And on this function, what we want is to take as a parameter the orb that we want to destroy, and then we can simply remove it from the list and then destroy the game object itself. So now we need to call this function from the ghost script. And at the top, what I'm going to do is simply add a public float called eat distance that we can set maybe to 0.3. There you go. And very simple here, if the minimum distance that we get from the orb is less than the eat distance, what we can do is simply get the orb spawner instance and destroy the closest orb. There you go. Now we can save, go back to Unity and try to see if it is working. Okay, and as you can see, this is what's going on. As you can see, it doesn't work very well. Now the answer is that we have actually made a little mistake on the way we are computing the distance, because we are actually getting the distance from the position of the ghost, which is at its feet, and it shouldn't be on its feet position. It should be at the center of the ghost. So to fix this, we can actually leave play mode. And here for checking the distance, what we can do is actually get the ghost position to be transform.position and then set the ghost position.y to be 0. And then do the same for the orb position with item.transform.position and set the orb position.y to be 0. So this way, by checking the distance from these two values, instead of directly the transform.position, we are making sure that on the y-axis they have the same value, which will give us the horizontal distance and will not take the difference in height between the two. So this should be a bit better. Now let's find out by clicking on play. And there you go. Now we have the 5 orbs that are spawned. Let's find out if the ghost can eat it when it reaches the orbs. And as you can see, it works, and the ghost even goes to the next one, which is the closest to him. And as you can see, it is working. Everything seems fine. Now you can even tweak the eat distance value. If you go back to the ghost, for example, in my case, I think the eat distance can be good if it's set to maybe 2.2. And there you go. But of course, right now, let's see what happens if there is no more orbs. So as you can see, if the ghost have eaten all of the orb, nothing happens. So the ghost stays still, but nothing happens. So let's find out how we can trigger a game over when there is no more orbs left. Okay, so this will be very, very easy. On the destroy orb function, what we can do is check that the spawn orbs.count is equals to 0. So let's do this in an if statement. And if it's the case, it means that there are no more orbs in the scene. And in this case, we can either trigger a game over by changing, for example, the path through color and adding a nice UI. And that might be something that we will do in the future episode. But in this case, let's simply restart the scene by doing Unity engine.scene management.scene manager.load scene and load the first scene that we are currently at. Beautiful. Now let's save. And if we click on play, and there you go, let's find out what happens when there is no more orbs. And there you go, the scene is correctly reset, which is what we want. And there you go guys, the gameplay of our mixed reality game is looking good. The orbs are now spawning, the ghosts are chasing them, we can kill the ghost, and when there is no more orb in the scene, it is game over and we are relaunching the scene. A big shout out to the new Patreon which are on the screen right now. If like them you want to get access to the source code of this game and other exclusive content, join us, the link is in the description. A big shout out to Cognitive 3D, the sponsor of this series. So if you'd like to know more about your game and better understand your player, you can try the tool for free by registering with the link you will find in the description. Thank you for watching and see you soon. Bye bye.